Hello viewers, Centroids and Centre of Mass, question 1. So we see here that we have a 2 metre by 1 metre rectangle. Towards the left hand end of the rectangle we've got 3 holes drilled. So the left hand edge of the holes, each of them is 10 centimetres in from the left hand end of the rectangle. We have a 15 centimetre gap above the topmost hole. We have a 15 centimetre gap between each pair of holes, and we have a 15 centimetre gap between the bottom hole. We also see that the top and bottom holes are the same size, and by symmetry the 20 centimetre hole is right in the middle. So we have a vertical symmetry. It is its own reflection around that dotted line, which is going to be at a height of half a metre, because it's 1 metre high and it's symmetric, so its vertical centre will be right in the middle. So at this point we can make the observation that the centre of mass in the y direction is at 0.5 metres. So we've got one of the coordinates of the centre already. We need to find the x coordinate of the centre, which is going to be, we'll have to find that now. We don't have any symmetry in that direction because all of the holes are not in the middle, they are towards the left hand end. So we will need to draw a table since we've already worked out what our y coordinate is. So we need to work out our laminae, which is just a way of saying shape. So the first one we'll deal with is the rectangle. We'll work out the area of each shape. We'll work out x bar, which will be the centre of each part of the shape, its coordinates, and a times x bar, which will be obtained by just multiplying the previous two columns together. Now we've already observed that in the vertical direction, in the y bar direction, we have symmetry, and that can be useful as well for finding x bar, because we have 3 options. We could find x bar for the whole shape, we could find x bar for the bottom half of the shape, or we could find x bar for the top half of the shape. Those are the 3 options that we have. We could choose either one because we should get the same x bar value, the same centre in the x direction for all of them. That's because we've got symmetry in the vertical direction. Now we'll define our origin to be the bottom left corner here, and we don't really want to work out x bar for the whole shape because that means that we'll have to work out all 3 holes, whereas if we only work with one of either the top half or the bottom half, we have one less hole to deal with. And because our origin is in the bottom left corner, we will work only with the bottom half of the diagram. So we'll only find the centroid in the x direction of this half of the shape that we've got here. Okay, so we've got the rectangle is 2 metres wide and the height is 0.5 metres, dealing, remember, with only that bottom half, means the area is 2 times 0.5, which is 1. Now at the centre of the rectangle, just the rectangle alone, not worrying about the holes yet, is it's a rectangle, so it's halfway along, half of 2 metres, which is 1 metre, and a times x bar is 1 times 1, so that is 1. Okay, so that is for the that's for the rectangle. Now we'll deal with the 2 holes, the 2 circular holes. So we've got the one at the bottom, which has a diameter of 10 centimetres. which is 0.1 metres. We need to find its area, which is going to be, we can work in terms of pi r squared. The radius is 5 centimetres, which is 0.05 metres. Area of a circle is pi r squared, so this is going to be pi times, as we said, the radius is 0.05, and this is squared. It's a hole, we're removing mass, so it's going to be negative, and this turns out to be negative 0.007854. Let's find where the central position of this hole is, which will be where is the centre relative to the origin. In particular, how far along is the x-coordinate of the centre. So its left-hand end is 10 centimetres to the in, and then the radius is 5 centimetres, so we're going 10 centimetres plus 5 centimetres gets you to the centre of the hole, which is going to be 15 centimetres, which is 0.15 metres. Now we've got this number here, negative 0.007854 times 0.15 gives us negative 0.00118, and that is for the top hole, for the bottom hole, sorry, that's for this hole. Now we need to deal with this hole. Because we've used symmetry to divide the shape into half, and dealing with the bottom half, we're only going to deal with the bottom semicircle from this one. So this is going to be a semicircle here. We've got a diameter of 20 centimetres, which is 0.2 of a metre. So its radius will be half of that, which will be 0.1 of a metre. So pi r squared for a full circle. We're dividing by 2 because we're only working out the bottom half of this hole, because we're finding the x bar for the lower half overall. So that's pi over 2 times 0.1 squared. Again, it's a hole, we're removing mass, that's negative, and if we calculate that, we get negative 0.0157. Now, where is the centre of this hole? So we've got 0.1 of a metre in here, and it's 20 centimetres in diameter, so halfway along will be only 10 centimetres. So its centre will be 0.1 of a metre plus 0.1 of a metre, giving you 0.2 of a metre. And if we work out 0.0157 times 0.2, we get 0.00314, and that is negative. Okay, so that's all we had to do as far as parts of the shape that are in the bottom half. And let's get our totals. So our total for the area is going to be 1 minus negative 0.007854 minus 0.0157, giving us 0.976. We don't need a total of the x bar, but we need the total of the ax bar, which is going to be 1 minus 0.00118 minus 0.00314, giving us 0.9956. Okay, so we need to find our x bar, our centre of the whole shape, which is going to be the sum of the ax bar column divided by the sum of the area column, which is 0.9956 divided by 0.975976, and calculating that gives us an answer of 1.02 metres. So the centre is at the point xy is x bar we found to be 1.02, and y bar we said by symmetry right at the beginning is 0.5. So obviously with 0.5 makes sense because of symmetry in the vertical direction. Now what about 1.02. Does that answer make sense? Well, it's going to be approximately halfway along. We have taken some mass out of the left hand side of the laminar, so therefore, since we've taken mass out of that left hand side, that's going to move the centroid to the heavier end will be the right, and therefore we expect the centroid to be just to the right of the midway point. So just, in other words, just over 1, and that's indeed what we do see. Thanks for watching. Over and out.